I'm looking at a situation where I want to write the equation of a line that contains a point and is parallel to another line that I've been given. I know that I can write the equation of any line if I have one point and I have the slope. I am not told the slope, but because it is parallel to this line, parallel means that they should have the same slope. So what I need to do first is find the slope of this line. Okay, I'm going to copy it. Oops, there we go. And trying to get rid of these extra tabs here. There we go. If I want to find the equation of this line, I need to solve for y so that I can find the slope from slope-intercept form. So the first thing that we're going to do is add 5x to both sides to move it to the other side. So if I add 5x to both sides, that negative 5x will move to the other side, becoming a positive 5x plus 4. Okay? Now if I divide both sides by 2, I'm going to take this entire side and divide it by 2. Let me write this in a different window so I can type this a little better. Okay, if I put it in this other window, having the 2y equals the 5x plus 4. Okay, if I divide both sides by 2, there we go, now I can divide a whole side by 2, and on the other side, if I divide that all by 2, we are going to be able to divide out those 2's on this side to get just y, and on this side we're going to be able to distribute the division so that we're going to have 5 divided by 2x plus our other fraction, which had the 4 divided by 2. Now 4 divided by 2, that simplifies to just 2, so I can reduce that one, and anytime you have an x in the numerator of a fraction, you can slide it off the edge. So I've taken the equation that I was given, and I've solved it for y. So it originally was 2y minus 5x equals 4. That was the equation in its original format. If I solve for y, it becomes y equals 5 halves x plus 2. The reason that I solved this for y was to find the slope, which is the coefficient of x. Now I know that the m value, the slope, is 5 halves because I solved that equation for y. I don't need this equation anymore. Its sole purpose was to give me the slope of this line, 5 halves. Now that I know the slope of the line, I am going to write the equation y equals mx plus b for our new line that goes through the ordered pair 2, 5. Okay, let me rewrite that real quick in an equation. Y equals mx plus b. Now, I know the m value because I just found it from my parallel line. It's 5 halves. So I can plug in 5 halves for m. I also know an ordered pair that gives me a pair of xy values. In an ordered pair, the y value is 5, and the x value is 2. If I begin simplifying this, I can solve for b. I know that 5 halves times 2, since 2 is 2 over 1, we can rewrite this as 5 times 2 is 10 over 2 times 1 is 2, so I can rewrite that as 10 halves plus b. Then we're going to subtract that from both sides to get b by itself. I need to do 5 minus 10 over 2, and 10 divided by 2 is actually 5, so I can change that to 5 minus 5. That's 0, so b is 0. Okay? That means that our equation, which is y equals mx plus b, in this case, I had an m value of 5 halves. So my m value is 5 halves, and I just found the b value is 0. I don't have to write in a plus 0, so I can just write this equation as y equals 5 halves x. Okay. That would be the equation of this line. So to reiterate some of the points that we were talking about, I wanted to find an equation that was parallel to this line. The only purpose of the original line was to find its slope. Parallel lines have the same slope. I solved that line for y, so I was able to identify the slope of that line. I'm not going to use the rest of that line, I only used it to get its slope. Once I know what its slope is, I'm going to use that slope, 5/2 in this case, with the ordered pair and y equals mx plus b form, plugging those in for x and for y, to solve for the b value. Once I have the m value and the b value, I can write my brand new line that satisfies that condition.